Welcome back. Problem 9-31. This problem is taken from chapter number 9, that is stress transformation, and book name is Mechanics of Material by R.C. Hibbeler. So statement is determine the principal stress at point A on the cross section of the arm at section AA. Specify the orientation of this stress and indicate the result on the element. So you can see this is the arm that is having a pin support at point B, and there is a roof which gives support to this arm, and there is a load of 500 Newton is applied. So you have the cross section at section A is shown over here, that is I beam. So you have to find the principal stresses at point A and then specify the orientation and indicate the result on the element. So let's start with the solution. So first step is that we will determine the support reaction. So I will write it support reaction on arm, reactions on arm. So what we will go do is that you can see this is the arm, and if you remove this support, pin support at point B, so you will be having a horizontal reaction force which is Bx, and there will be a vertical reaction force which will be represented as Py. And if you can see that this is the rope CD which exert a force of FCD on this arm, and that makes this angle is 30 degree, because this is 60, this is 90, and this will be 30 degree. So we'll apply equation of equilibrium. That first equation of equilibrium is that sum of all moments about point B is equal to 0, and taking the counterclockwise moment as positive. So you can see this is the point B. These two forces are not producing movement because they are passing through it. So we have only two forces, FCD and 500. One is known and other is unknown. So you can find FCD. Okay, so this FCD will have two components. One is along x-axis, which is FCD x component, and other one is this y component, which is FCD y component, and this FCD y component will be equal to FCD into sine of 30 degree. Clear? And FCD x will be equal to FCD cos of 30 degree. So you can see this FCDX is passing through this point, so it is not producing movement. So only the force which is producing movement is this FCDY, and the perpendicular distance is this one, which is 0.3, and this is producing counterclockwise movement, so it will be positive. So I will write it FCD into sine of 30 degree multiplied by perpendicular distance is 0.3. The second moment that is produced due to this 500 Newton load and perpendicular distance is this one, which is equal to 0.65. This is 0.3 and this is 0.35, so it is 0.65, and it is producing clockwise movement, so it will be negative. So I will write it minus 500 into 0.65 is equal to 0. So when you calculate it, you will get FCD will be equal to 500 into 0.65 divided by sine of 30 degree multiplied by 0.3, and that will give you 2166.67 Newton. So this is FCD. Clear? Now we'll find this Bx and By by using equation of equilibrium, that sum of all forces along x direction must be equal to 0, and force in this direction is taken as positive. So Bx, which is acting in positive direction, and the other force along horizontal is this FCDx, will be equal to, their sum must be equal to 0. So I will write Bx minus FCD x component is equal to 0. So from here, Bx is equal, Bx minus FCDx is FCD cos of 30 degree is equal to 0. So Bx will be equal to FCD cos of 30 degrees. So you have the value of FCD, which is 2166.67 into cos of 30 degree. That will give you Bx. So Bx will be equal to Bx will be equal to 1876.39 Newton. Now we'll find By by using equation of equilibrium that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see one force is upward is this one, the second one is this one, and third one is downward. Their sum must be equal to 0. So upward force is taken as positive. So By clear minus minus 500 which is downward plus FCD y component which is equal to FCD is 2166.67 into sine of 30 degree is equal to 0. So when you calculate it, you will get By is equal to minus 583.33 Newton. So this value is negative. It means that our assumed direction is wrong. It should be downward. So By should be downward. So I will write assume direction of By is wrong and it should be downward. Okay, now we have all these reaction forces. So what we will do is that you will cut this beam or arm at section AA and draw the free body diagram of this portion. Clear? So let me draw it. I will write internal loading. We are going to find internal loading at section AA in order to show what are the forces acting over here. So when you section it at this point, so this is section AA and this will be the beam like this, not like this. It will be like this. So this is point Bx. So B, this is point B. So we have Bx in this direction, clear, and By is in downward direction because we have find out that it should be in downward direction By. And the distance from this point B and section AA is 0.15. You can see over here this distance is 0.15. And when you section it, so you will be having a normal force at this point, and this normal force should be opposite to this Bx, and you will be having a shear force that will be acting upward, and there will be a movement which will be in clockwise direction. So we'll find this V, M, and N by using equation of equilibrium. So what are these equations? So first equation is that sum of all forces along x direction must be equal to 0 and force in this direction is taken as positive. So Bx is in positive while N is in negative. So Bx minus N is equal to 0. So it means that N is equal to Bx and Bx is 1876.39 Newton. Now we will find this V shear force, and for that we will apply sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So V is upward, so V minus By is equal to 0, and from here we will get V is equal to By, and this By is 583.33 Newton. And we will find this M by using equation of equilibrium that sum of all forces about this point, that this is point O, about point O is equal to 0, or section AA is equal to 0, and taking the counterclockwise movement as positive. So you can see these two forces are not producing movement because, and this one, because it is passing through point O, so only movement is producing is this By about point O, and perpendicular distance is 0.5. This is producing counterclockwise, so it will be positive, and this external movement which is M, that is negative. Their sum must be equal to 0. So I will write it 583.3, which is by, into perpendicular distance is 0.15, minus this m is equal to 0. And from here you will get this moment will be equal to 87.5 Newton into meter. Okay, now you can see that you have this normal force, you have this shear force, and you have movement. So due to this normal force, you will be having a normal stress. Due to this shear force, we will have a shear stress. And due to this movement, and due to this, it will be bent like this. Okay, it will be bent like this. Clear? So here we will have normal stresses and shear stress. So let me write it: normal stress and shear stress. So normal stress, which is represented as sigma, will be the combination of this normal stress due to this compressive load, which will be equal to minus n by a, plus due to this moment. Clear? And this moment due to this by, it will bend like this. So we are interested to find out at section AA. So the upper layer will be in tension, so the bending stress will be positive. So it will be equal to plus m into y divided by I. Clear? And due to shear stress V, shear force, we will be having shear force which is equal to V into QA divided by I into T. So first we will concentrate on normal load. For that we need A and I, which are the section properties. So you can see over here, if I take it toward downward, let me copy it, and paste it over here. So you can see this is the cross section. So what we will do is that we'll find the area, and this area is equal to, area of this will be equal to, if we take this whole as a rectangular box having dimension 20 by 50, so and then we'll subtract these two portions, so we will get the area of this I beam. Clear? So I will write it, the area will be equal to this width, which is 20 millimeter. So in meter it is 0.02 meter, and the height is 50 millimeters, so 0.05, minus this height. This height is, again you can see, 50 minus 7.5 minus 7.5, which is 35, and 35 is minus 0.035. Clear? Into this width, which is, you can see this is 20, this is 7.5, so that will give you 12.5. So 12.5 will be the distance remaining two portions, so minus 0.0125. Clear? And when you calculate it, you will get the area will be equal to 0.5625 into 10 raised to the power minus 3, and unit will be square meter. Now I'll find this I, and you can find this I by using equation. I is equal to, for I beam, you can see that this is, if you take the half of it. Clear? So you can see this is symmetrical above and below. So this will be the neutral axis or centroidal axis, so it will be equal to 1 over 12. B is 0.20 millimeter, which is 0.02, and the total height is 50 millimeter, which is 0.05 whole cube, minus the moment of inertia of these two hollow portion. So minus 1 over 12, breadth, which is the remaining, is 125, so 0.0125 meter, into height is 35 millimeter, which is 0.035 whole cube. So when you calculate it, you will get the moment of inertia comes out to be 0.16367 into 10 raised to the power minus 6 meter power 4. Now you have both I and A, so you can just put it in this formula. So what we will get is sigma is equal to minus n, and n is equal to 1876.39 minus divided by area is 0.5625 into 10 raised to power minus 3 plus moment which is 87.5 into y. Y is distance from neutral axis till the point A. So this is wide y. And this distance you can see this distance is 35. So 35 half is 35 divided by 2 which is equal to 17.5 millimeter. So in meter it is 0.0175 meter. So I will write multiply by 0.0175 divided by I is which we have calculated is 0.16367 into 10 raised to the power minus 6. And when you calculate it, it will be equal to 6.020 megapascal. So sigma is equal to 6.020 megapascal. Now we'll find shear stress. So for shear stress, we have V. We need V. So V is 583. So 583.3. And what about QA? So QA is equal to Y dash bar into area. So you can see A is this point. So above A, this is the area. This is the area. And this area is 20 by 7.5. So I will convert. I will write this area A is equal to 20. So 20 is 0.020 meter into thickness is 7.5 which is 0.0075 will be 7.5 millimeter is 0.0075 meter. Clear? And what will be the y dash? So y dash is distance from neutral axis till the mid of this section, this area. Let me zoom it from neutral axis till the mid of this section. And you can calculate this distance is 35 and this is 7.5 divided by 2. So this distance, total distance will be equal to 21 point, this distance will be equal to 20, this from neutral axis till the mid. This distance will be 21.25 millimeter. Why? Because this distance, this distance was 35. So this distance is 17.5 millimeter and this half of 7.5 will, when you add it, it will give you 21.25 millimeter. That will be equal to y dash bar. So let me write it here. So y dash is 21.25 millimeter or 0.2125 meter. Now you have both the values. So just put it in above. QA will become equal to y dash which is 0.012125. 2125 multiplied by area which is 0.02 into 0.0075 and you will get this QA will be equal to 3.1875 into 10 raised to the power minus 6 cubic meter. So put the value 3.187 into 10 raised to the power minus 6 divided by I, and I is this one 0.16367 into 10 raised to the power minus 6. And what about T? So T is this thickness which you can see that is 7.5 and 7.5 millimeter in meter is 0.0075. So when you calculate it, you will get the shearing stress at point A comes out to be 1.515 megapascal. Now you have both normal stress and shear stress. So if you want to represent on element, so it will let this is the element. Clear? So in x direction, this is will be sigma x, which is equal to 6, this 6.02 megapascal, 6.02 megapascal. In y direction, you do not have any stress, so sigma y will be equal to 0, and shear stress is this one plus 3.1.15. So it will be, the shear stress will be like this. This is tau A, or tau of xy is equal to 1.515 megapascal. So now we will find principal stress. For that, I have to copy all this and we will move toward our second page so that we can have all this. Let me copy it. Okay, and we will paste it over here. Resize it. Okay, now we have this state of stress. So you can see that we do not have sigma y, we have sigma x is equal to 6.020 megapascal. We do not have sigma y is equal to 0, and tau of xy is 1.515 megapascal. And in first part, we have been asked to find the principal stresses. So we know that principal stresses, which is sigma 1 comma sigma 2, sigma 1 comma sigma 2, or in combine you can write it like this. So it is equal to sigma x plus sigma y divided by 2 plus minus sigma x minus sigma y divided by 2 whole square plus tau of xy square. Clear? So just put the values in this formula. So sigma 1 comma 2 is equal to 6.020 plus 0 divided by 2 plus minus 6.020 minus 0 divided by 2 whole square, and tau of xy is 1.515 square. So when you solve this for plus value, so see, you will get sigma 1, and sigma 1 will be equal to 6.38 megapascal. And when you solve for negative, so you will get sigma 2 is minus 0.360 megapascal. So these are the principal stresses, and that is the answer of our first part. Now we will move towards second part, and in second part we have to specify orientation. We will find theta, or the angle for the plane over which this principal stresses acts. Clear? So we know that orientation of principal stresses. So we know that we can find it by using this formula. Tangent of 2 theta p is equal to tau of xy divided by sigma x minus sigma y divided by 2. Clear? So put the value. Tau is 1.515 divided by 6.020 minus 0 divided by 2. So you will get tangent of 2 theta p will be equal to 0.5032. And when you solve this for theta p, so you will get this theta p will be equal to 13.36 degree, or this will be theta p1 or theta p2 will be equal to minus 76.64 degree. So we will now specify these principal stresses on the element. So let me show you that this was the original element having normal stress sigma x in this direction. That was sigma x and tau of xy like that. This was tau of xy. Clear? And we have find this plane. So this was the initial x-axis. This was y-axis. Clear? So theta is 13.36, which is positive. So it means that this is counterclockwise. So your new axis or transform axis, this is theta p1 is 13.36 will be this one, and this will be your new y dash axis. And when you draw the element like this, clear? So normal sigma 1 will be, now we do not know that whether on this theta p1 what will be the value of stress. So what we will do is that, let me do it as well. Substitute theta 1 is theta p1 is equal to 13.36 in stress transformation equation, which is sigma x dash is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos of 2 theta plus tau of xy sine of 2 theta. Clear? So when you put sigma x and sigma y, let me put it as well. Sigma x is 6.020 minus 0 divided by 2 plus 6.020 minus 0. This is plus, this is minus, divided by 2 into cos of 2 theta. So 2 theta is 26.71 degree plus tau of xy, which is 1.515 into sine of 2 theta, and 2 theta is 26.71 degree. So when you solve this, you will get sigma x dash is equal to 6.38 megapascal. So it means that at an angle of 13.36 over that face, we have sigma 1. So we will represent the element over here. This is plus value, so it will be, this will be the, on this face it should be perpendicular, so this will be sigma 1. Clear? This will be sigma 1, and sigma 2 is negative, so it will be compressive. This will be sigma 2. Sigma 1 and sigma 2 are principal stresses. Clear? And this is the answer of our third part. These are the answer of specify the location, and the third part was indicate the result on element on the point stress. So this is the answer of our third part. And that was all about this problem 9-31. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.